don't know about y'all, but my favorite pastime when I'm on lockdown is gas laws and coming up with gas law power questions that also include vapor pressure, because what better time to do it than right now? Let's go ahead and go through this question. So it says a strip of solid magnesium is placed in water, and you know how much I like to draw pictures, so let's draw a picture out. We got some water, we place a strip of magnesium in it, which is really cool, by the way. You can actually burn it. It burns really, really bright. It's a great replacement for a birthday candle. And you place magnesium in the water and it produces H2 gas and also magnesium hydroxide, which is a nice little strong base, which would be aqueous, by the way, dissolved in water. And if we write this in terms of a reaction, essentially we get Mg plus water yields magnesium hydroxide and H2 gas. And if we balance this reaction, which we're going to want to, we're going to need 2 waters there, and everything should be balanced in that case. All right, so then the question goes on to tell you that that this happened in a closed container, that essentially they took a sample, the volume was 0.147 liters. It tells you the pressure of the gas collected is 784 torr, and gives us a little more information. The temperature at which this occurred was 35 degrees Celsius, which we're going to add 273.15 K, and that's 308.15 K. My dog decided now would be a good time to eat. All right, so this is all dandy. We wouldn't know the number of moles, but first of all, when we start seeing pressure, volume, temperature, number of moles, etc., we automatically ought to start thinking about PV equals nRT. But one thing is really important and noting is that they gave us this other piece of information. They said the vapor pressure of water at 35 degrees Celsius is 42.2 torr. So when we collected the sample over here, this wasn't just hydrogen gas. Don't forget that at anything above 0, we're gonna have water contributing a certain amount of vapor pressure. So water over here is also contributing some molecules to the gas. So when we talk about the pressure here of gas, we're talking about the total gas, not that of hydrogen. So if we're ultimately gonna go figure out the number of moles of H2, we first need to figure out the pressure of H2. So that way everything else aligns. So when we're looking at the pressure of H2, that's going to be simply equal to the vapor pressure of the total minus, or excuse me, the pressure of the total minus the stuff that's being contributed to from water. And if you do that, you get an answer of, I have it here, 741.8 torr. And what do we do with torr? We turn it into ATM. I feel like one of those cartoons where they ask questions and like just pause and pretend that kids are answering them. My kids totally answer those questions. We get 0.97605 ATM. All right, now we have volume, we have the pressure of the actual gas we're interested in, which is H2. We have the temperature of the H2, and now we can figure out the moles here using PV equals nRT. So let's go ahead and plug that in. 0.97605 P, this would be our pressure, torr, or excuse me, ATM, times the volume collected, 0.147 ATM. I can do it. Liters is equal to the number of moles, which we're solving for, of H2, times the gas constant, 0.0821 liters ATM over mole K, times the temperature, which we determined in Kelvin is 308.15 Kelvin. If you do this, you multiply this times this, divided by the 0.0821, divided by the 308.15, you get an answer of N is equaling to 0.05671 mole of H2. And ultimately this could have 3 sig figs, because here we had 3. When we added, even though this had 2, we're looking at the ones place. So when we added it with this, we actually got an answer that would have had 3 sig figs. So 3 sig figs, 3 sig figs. What a coincidence, this one also has 3 sig figs. So our final answer should be in 3 sig figs. If we were just stopping right there, it would be 5.67 E negative 2. But that's not where we're stopping. The next question says, that's great, we figured out the moles of H2, how many grams of magnesium would there be? Well, now we have to use stoichiometry, so it was important that we balance the reaction. For every 1 mole of H2, we had 1 mole of magnesium, so this switch shouldn't be too difficult. We say we got 0.05671 mole of H2. We know for every 1 mole of H2, we had originally used up 1 mole of magnesium. It asks the question in grams. So we also know that 1 mole of magnesium has a mass according to the periodic table of 305 grams. And if you calculate this out, you get an answer of 0.138 grams of magnesium. So pretty cool. Don't forget to pay attention essentially to vapor pressure. So anytime you have a reaction occurring, it's something about a gas law, and there's something with water. To figure out the pressure, you have to subtract off the vapor pressure first so that it's not interfering with your answer. Otherwise, you'll get an overly inflated answer. And yeah, I hope that helps. Have a great one. Bye, y'all.